Okay, the last thing we want to talk about is rational zeros theorem so that we can understand how to begin looking for the real zeros of a polynomial. So here's the rational zeros theorem. It says let f of x be a polynomial function with coefficients that are integers, meaning no fractions or anything like that, just either positive or negative whole numbers. The only possible rational zeros of f of x are positive and negative p divided by q, where p is a divisor, or maybe a better word here is factor of the constant term, and q is a divisor, or probably a better word is a factor of the leading coefficient. And so we're going to use this theorem as a jumping off point to find all of the real zeros of polynomials. And so here in example 6, we're going to find the real zeros of the function 6x cubed minus 29x squared minus 6x plus 5. And the first thing that I'm going to do when finding these real zeros is I'm going to find what are called the possible rational zeros, or sometimes abbreviated PRZs. And so this is going to be step 1. In order to do this, I need to find my p's and my q's. And so looking back to the theorem, p is the factor of the constant term. And so what are the factors of the constant term here? 5. Well, that would just be 1 and 5. Those are the only two factors of 5. For q, that's the factors of the leading coefficient, and the factors of 6 are just 1 and 6, 2 and 3. And so now when I find the PRZs, this is going to be positive and negative, all of the p's divided by each of the q's. And so if I take 1 and 5 and divide by 1, that's just going to give me 1 and 5. If I take 1 and 5 and divide by 6, that's going to give me 1/6 and 5/6. If I take 1 and 5 and divide by 2, that's going to give me 1/2 and 5/2. And if I take 1 and 5 and divide by that last q, which is 3, that's going to give me 1/3 and 5/3. And so what this list does is it gives me a possibility for some rational zeros. Now, I don't know if they're actually rational zeros until I synthetic divide by them, or what we're going to do is use the calculator to determine what they are. And so if you use your calculator, what we're going to do first is go to the y equals screen, and hopefully we can get it to turn on. There we go. And we're going to plug this polynomial into our y equals. And so we're going to have 6x to the third minus 29x squared minus 6x plus 5. And the first place I'm going to go is to the second window screen. So you should be seeing this on your calculator if you're using a TI-84. And I'm going to change the independent variable from auto until ask. And I'm going to hit enter so that that is bolded back there in black, and that's chosen, ask for independent. Go ahead and leave the dependent variable on auto. And then I'm going to go to second graph to get to my table. And because I changed it to ask, my table is now blank. And so I'm going to be able to plug in values from this list of possible rational zeros. And so I'm just going to start with the first one, which would be positive 1. And I see that that is not a 0. What if I try negative 1? That is also not a 0. What about positive 5? That is a 0. And so I'm going to write that one down. X is equal to 5 is one of my zeros. What about negative 5? No, that doesn't work. Okay, what about 1 divided by 6? That doesn't work. I could try negative 1 divided by 6. And I basically just keep trying these numbers until I get one. And so what about 5 divided by 6? That is not going to be a 0. And so what you could do is, if you're at the bottom of the list, you could go back up here to the top and then just start hitting the delete button so that those delete out of there. What if we try positive 1/2? That is not an answer. What about negative 1/2? that is an answer. And so I'm going to have another 0 here. X is equal to -1/2. Now that is going to be 2 of my 3 zeros. Notice that this is a polynomial of degree 3. That means I know there are going to be 3 zeros. And so I'm going to stop this process of finding rational zeros in the calculator, and I'm just going to start synthetic dividing. And so just choose one of those first zeros, and let's just say 5, and then let's just list the coefficients of our function. Leave a little bit of space here, and go ahead and drop down the first number. So 6 times 5 is going to be 30. Add to -29, that's going to give you 1. 1 times 5 is 5, and so that's going to be -1. And -1 times 5 is -5 for a remainder of 0, just like we anticipated since we got that number from the calculator. Now take your other 0, -1/2, and go ahead and synthetic divide by it as well. So we drop down to 6. 6 times -1/2 is -3. That's going to give me -2 right there. And then -2 times -1/2 is +1. And adding to -1 gives me a remainder of 0. And so just like before, as we've talked about in these notes, that started with x cubed. We divided the first time, that got me down to x squared. That means when I divide the second time, I get down to x. And so my last factor is going to say 6x minus 2. And so if I want to get the 0 of that, I just set that equal to 0 and go ahead and solve. And so x is going to equal to 1/3, and that's going to be my final 0 here. X is equal to 1/3. So once again, we got these first two from the calculator, and the third one came from synthetically dividing by the 2 zeros we got out of the calculator and then solving the last line.